Okay, so good afternoon, class. So this is our lecture in linear programming using the simplex method. So the simplex method is a general mathematical technique for solving linear programming problems. So unlike the graphical method, which is only applicable to problems with two decision variables, simplex method can handle problems with several decision variables. So all problems that we previously solved using graphical method can be solved using the simplex method. But there are problems like LP problems with more than two decision variables, which can no longer be solved using graphical, but which can be solved using the simplex method. So this is a more general method of solving linear programming problems. So this method applies an iterative techniques, and it makes use of row operations in moving from one feasible solution to the next until the optimal solution is reached. Okay. So these are the steps in solving LP problems using the simplex method. We start by converting the model, the LP model, in standard form. So it is assumed that you have already converted the linear programming problem into a linear programming model. So that means you have already formulated your objective function, you have the constraints. So the next step after formulating the linear programming model is to convert the model in standard form. So that is, you will be converting the inequality explicit constraints into equations. And then the next step would be to set up the table. And then in preparation for the next table, you select the entering variable, the leaving variable, you compute the entries in the replacing row, then you compute the new entries in the remaining rows, and then the last two rows, which are the z's of j and c's of j minus z's of j rows. And then step 8 is to check if the table that you constructed is already optimal. If it's not, you go back to step 3, and then you continue the process until you come up with the optimal solution. Okay. Okay, so in the first step, in converting the LP model in standard form, we apply the following rules. If it's a less than or equal to explicit constraints, you convert that constraints into equation by adding a slack variable. So yung SI. If it's a greater than or equal to constraints, katulad nito, what you will do is you will subtract a slack variable or a surplus variable and add an artificial variable. So the symbol for the slack and the surplus are the same, use S. And then if it's already an inequality constraints, you still need to add an artificial variable. So you add an a sub I to the left side. Okay. Now the slack variables in the less than or equal to constraints, they represent unused resources. So if that constraints for instance, is associated with assembly time, so the slack associated with that constraint represents the unused assembly time. Surplus variables, on the other hand, represents the amount above the right-hand side value. So if that constraint, for instance, represents the minimum requirements for calories, so the surplus variable represents the amount above the minimum requirements for calories. So the artificial variable, they do not mean anything. They are just added into the equation in order to solve the negative value of the surplus. Remember that for greater than, the left side is greater than the right side. So instead of adding something on the left side, we subtract something. However, if we subtract a quantity on the left side and the decision variables are assigned 0 coefficients, okay? If they are assigned 0 coefficients, okay, let's say the constraint is x plus y. Oops. Okay. Let's say the constraint is x plus y greater than equal to 10. If this will be converted to equation, of course, the natural thing to do, since the left is higher than the right, if you will be converting it to equation, is to subtract from the left side. So magsusubtract tayo ng s so that it becomes equal to 10. However, in the initial table, we always assign a zero value to the decision variables x and y. So if we assign a zero value to x and y, what happens is that your S will have a value of -10, which is not allowed. Remember that one of the requirements for LP is that all the variables that you will use should have non-negative values. So to solve that possibility, we add an artificial variable. So the purpose of the artificial variable is just to remove that problem of having a negative value for the surplus variable. So because we do not want the artificial variable to appear in the final solution, in fact, they will not appear in the final solution. So we assign a very small value to the artificial variable for maximization and a very high value for A sub I for minimization. Kasi kung maximization, di ba, the higher the coefficient of the decision variable, they are more likely to appear in the optimal solution. Pag minimization naman, the lower the numerical coefficient of that variable, they are more likely to appear in the final solution. That's why in maximization, since we do not want the artificial to be included in the final solution, ang gagawin, a-assignan siya ng maliit na value. So in our discussion, so some books would assign M to the artificial variable, but to remove the M's in the final table, ang gagawin natin, kapag maximization, the artificial variable will be assigned -10. So in some books, you will see -M here. Okay? Tapos pag minimization plus M. Just so we will have real values, pag minimization, we will assign a power of 10. So pwedeng 10, it can be 100, it can be 1,000, depending on the highest numerical coefficient of the decision variables. Remember sa minimization, so that it will not be a potential variable to enter the basic variables in the simplex table. We do not want it to appear, so we will assign a high numerical coefficient. So if the highest coefficient of the decision variables, let's say, is 9, so it's a 1-digit number. The lowest power of 10 higher than 9 is 10. So the numerical coefficient of the artificial variable will be 10 in the objective function. But if the highest numerical coefficient of the decision variable, say, is 23, so the lowest power of 10 higher than 23 is 100. So ang i-assign natin, the numerical coefficient ng artificial variable is 100. So we will initially put the artificial variable in the table, but once it becomes a living variable, we can already delete the column allotted for the artificial variable. Okay? Okay, so we will illustrate the steps in solving a linear programming problem using the simplex method in this particular LP model. So we have maximized z equals 9x of 1 plus 6x of 2, subject to x of 1 plus 2x of 2 less than equal to 14, 3x of 1 plus 4x of 2 less than equal to 36, and the non-negativity constraints x of 1, x of 2 greater than equal to 0. So the first step is to convert the inequality explicit constraints into equation. So what will be done here is this will be converted to equation. Okay. So since it's a less than constraints, okay, what will happen is to convert the equation to the inequality constraints to equation, we will add a slack variable on the left side. So since it's the first slack variable that will be added to the model, we assign S1. Okay, so we add S1 on the left side and then change the symbol from less than equal to equality. So we do the same for the second constraint. So instead of less than equal to 36, we will add a slack variable on the left side. So we add S2, kasi pangalawa na siya, and then change the symbol to equality. So that means in the constraints, we added two slack variables. So we will also add the slack variables in the objective function. So instead of just z equal to 9x1 plus 6x2, now we will have a 0s1 plus 0s2. Yan. So that's called this is the new LP model. Okay. So this is the structure of the simplex table. Okay. So ito siya. So what we will do is we will now enter the coefficients. The coefficients of the variables in this LP model into this structure of the simplex method. So we have a fixed C sub j row, a fixed C sub j column. So all the entries in this row and column are actually numerical coefficients of the variables in the objective function. Okay. And then we have the fixed column for the basic variables, the fixed column for quantity. So quantity is actually the right-hand side. And then for the succeeding columns, we will allot one column per variable. So we have x1, we'll have one column for x1, we'll have another column for x2, another column for s1, and another column for s2. Ayan. So ito na yung structure natin. Then the next step is to enter the numerical coefficient. As I mentioned, yung C sub j natin, these are for the objective function. So for x of 1, for the column for x of 1, what we will enter in the first row is 9. Since the numerical coefficient of x of 1 for x of 1 is 9, the numerical coefficient of x of 2 in the objective function is 6, so we enter 6. And for the slack variables, we have 0. Pareho yung 0. Okay. So after the labels, the basic variable, the labels for the columns, the next would be the body of the simplex table. So each constraint will have a row in the body of the simplex table. So this first row here is allotted for the first constraint. Okay, so I mentioned earlier that in table 1, okay, so I'll just name this as table 1. Okay. You start with 0, 0, so the origin. So that means our x1 and our x2 will have 0 values. So what you will enter in the basic variable is the remaining variable in the constraint, which is s1. So kapag may slack ang ilalagay natin sa basic variable. For the quantity, we enter the right-hand side value, so that's 14. And then we enter the numerical coefficients. We have 1 for x1. We have for x of 2. We have 1 for s of 1. We don't have s of 2, so we enter 0. Okay. And for the next constraint, in addition to the original decision variables, we added s2. So that's what we will enter under the basic variables. For the right-hand side, we have 36. For x of 1, we have 3. For x of 2, we have 4. We don't have s of 1, so we write 0. And then we enter 1 for s of 2. Okay. Again, this is for the objective. Dito galing din sa taas. The numerical coefficient of the slack variables are 0. So we enter 0 here. And 0 also for s of 2. Okay. So the next step would be to compute the C sub j entry. The formula here is, so for this particular entry, you get this. So let me just write it. Okay. So the entry here is 0 multiplied by 14 plus 0 multiplied by 36. So whatever the sum is, that's what you will enter here. So ganun yung process. For the next cell, ganun din. So it's going to be the left-hand side multiplied by the entry in that column. Then you add them all up. So that is what you will enter in C sub j. But instead of doing it manually, we will just ask Excel to do the computation for us. So that means, let me just remove this one. But anyway, these are all zeros. So we expect that all the entries in the C sub j row will be 0. So we can just enter 0 here. Okay. Kasi 0 times any number naman is 0. Okay. Then for the last row, sabi naman C sub j, For maximization, baliktad. It's going to be C sub j minus Z sub j. So it's going to be C sub j. Oops. C sub j minus Z sub j. Pag minimization, mauuna yung Z. So that's 9 minus 0. So equals 9 minus C sub j. Okay. So then, copy lang natin onto the next row. So this completes our table 1. Okay. Then let's see, is table 1 already optimal? Of course, we expect that this is not yet optimal. Okay. When is a maximization table optimal? It is optimal if all the entries in the last rows are either zeros and negative. But since we still have 2 positive entries here, that means this table is not yet optimal. So the next step would be to choose the entering variable. The entering variable is the variable with the highest entry in the last row. So among the entries in the last row, 9600, ang highest positive natin is 9. So we choose the column for x1 to be our entering variable. We choose x1 to be the entering variable. So that means, guys, this is our pivot column. Okay. So this is our pivot column. Okay. So this is our pivot column. And x1 is our entering variable. Okay. Next, to determine the leaving variable, we perform the test ratio. Test ratio is carried out by dividing the entry in the quantity column by the entry in the pivot column. So, laging ganon, quantity divided by the pivot column. So ang formula natin again is quantity divided by pivot column. Okay. The first row is 14. For the second row, it's 12. So choose the lowest. So this one is the lowest. Lowest positive. By the way, guys, we're not supposed to divide if the entry in the pivot column is 0 or negative. So they will disqualify already for the leading variable. So since the lowest quotient is 12, so that means S2 is our, okay. So S2 is our pivot row. Okay. So ito guys yung ating, okay, para may labels lang. I'm just doing this for the first table, but I'm not gonna do this in the succeeding table. So this is our pivot row. And S of 2, this is the leaving or outgoing or leaving variable. Okay, so yan. And 3, by the way, the intersection is our pivot. So yan. So that completes our table 1. Okay, the next step would be to set up the next table. So we will set up table 2. Okay, so in table 2, the first row that we'll create is the row allotted for the replacing row. So sabi dito, the entering variable is x1 and the leaving variable is s2. Because what will happen, guys, is in table 2, instead of having s1 and s2 in the basic variable, what we will have are s1 and s2 will be replaced by x1. Okay, so ang ipapalit natin sa s2 si x1. So x1 na ngayon to. So instead of previously s2. So we have to put the new entries here. So this is what we call the replacing row. Okay. And the new entries is obtained by dividing the entries in the pivot row by the pivot. So that means 36 divided by 3, 3 divided by 3, 4 divided by 3. So ganun yung gagawin natin. But if you're using Excel, so we just click equals to start formula. Click on the old entry in S2. what we're gonna do is we will divide it by t. But since all of them will be divided by t, I will convert this into an absolute reference. So I click 4 so that instead of just I5, we will have $I, $5. Diba? So it's an absolute reference. So 12 na yon. So ang next, ang i-divide naman natin, 3 by 3. But since we have already entered the formula for the first cell, we can just copy it onto the succeeding cell. So this one is 3 over 3, 1, 4 over 3, 1, and 1.33, 0 over 3, 0, and 1 over 3, 1/3. But of course, we want the entries to be fraction. Okay? Para captured lahat. So we'll change. Okay. Yan. So na 1 and 1/3. Okay guys? So paano nakuha to? Itong mga numbers na to. The formula here is, okay. The formula here is pivot column, pivot row divided by the pivot. Okay, so entries in the pivot row divided by the pivot. Now for S1, the formula naman is yung old S1, meaning old S1, yung S1 natin sa table 1, minus the entry in the pivot column. So si 1 yon, minus 1 times the replacing row. Okay, so that replacing row yung naka-red, yung the one that we have just computed. But since the multiplier is 1, ang gagawin lang natin equals 14 minus the replacing row. So minus 12. Okay, so yan. So ganun din sa iba. 1 minus 1, 0. Yan. So clear tayo guys so far. Okay, so yan. Old S1 minus 1, saan galing yung 1? 1 is the entry in the pivot column. So this one came from the pivot column. Yan. Okay. Oops. Yan. Pause. On the left-hand side, we entered the numerical coefficient. So we have 0. Then we have, for x1, the numerical coefficient is 9. This time, the entries in C sub j will no longer be zeros. But instead, it's going to be 0 times 2 plus 9 times 12. So we enter the formula here, equals click on the cell that contains 0. But since this will always be in column F, we convert it into mixed reference. We just want dollar symbol to appear in column F and no dollar symbol before 12. So multiplied by 2 plus 9. I'm fixing 9. So again, I'll press F4. So until the dollar symbol remains before F, multiplied by 12. Okay. So, kung nagawa nyo yun, yung converting into mixed reference, we can just copy onto the succeeding cells. So since we already entered the formula here, guys, yung 9 minus 9, so automatic nang lumabas yung C sub j minus Z sub j. Okay? So yan, since all the entries here are zeros and negative in the last row, then it means that this table is already optimal. Okay, so since the table is optimal, then we can have our final solution. The final solution is actually this part. Okay. Let me just highlight them. Okay, so ang optimum solution natin, okay, our x1 is 12, kasi yun yung value niya. Don't see x2 in the basic variable, ibig sabihin 0 yon. Maximum z is 108. You actually have a slack variable of 2 for the first constraint. We have S1 equals 6. Pero kahit hindi yun yung S1. Ito lang naman yung tinatanong dyan, X1, X2, and maximum z. Do you have questions, guys?
Saan po ulit yung...
Ala, nakastop pala yun. Ayan. Hindi na-record, guys. Nag-post recording ako, hindi ko na-resume. Anyway, may record na ako nito. I will just share it with you. Okay, guys? question?